Everyone, my name is Jacqueline Gerakis, and I'm the Expeditions Manager for EarthEcho International. We are so excited to have students from all over the globe joining us today as we learn about dead zones, the scourge of our ocean. EarthEcho International is a global nonprofit founded on the belief that youth have the power to change our planet. Reaching more than 2 million people in 146 countries, we provide original content, immersive experiences, and trusted resources to empower young people to become leaders and problem solvers in their communities and around the world. Just a reminder that you can send in questions for our host, Dr. Sturdivant, via chat today. We will break throughout the presentation to see what questions you have. Feel free to start typing them in the chat space in YouTube or the question and answer feature if you're watching in the Zoom room. And we'll be sure to answer those as we go along. So let's get started. Please join me in welcoming our special guest and host for today's virtual field trip, Dr. Kirsty Sturdivant. Dr. Sturdivant is a marine ecologist who studies the effects of human disturbance on the seafloor and develops marine technology to enhance human understanding of the ocean. Presently, he is a principal scientist at Inspire Environmental, adjunct assistant professor at Duke University, senior correspondent at southernfriedscience.com, and co-creator of Oceanography for Everyone. All right, Kirsty, go ahead and take it away.
Well, Baines, let's just share my screen. And please let me know when you're able to view.
Looks good.
Awesome. Okay, so a brief aside before I begin, if you want to live tweet this talk, you can tweet at WormCam, which is shown in the lower left of this first screen. So today we're talking about dead zones. And I think before we dive into what they are, how they're affecting our oceans, it's important to take a bit of perspective. When you view Earth from space, what do you see? It's predominantly this pale blue dot. And that's because the planet that we live on is covered by the oceans. Approximately 70% of the Earth's surface are the oceans. And when given the spatial extent of the oceans on Earth's surface, it should really come as no surprise that this vast body of water plays a key role in life on our planet, including the lives of humans. Ocean processes influence all of humanity, whether we're residents of the coast or inland, via the regulation of climate, local weather patterns, economic impact, food security, among many others. So we're inherently dependent on the health of the global ocean ecosystem, which under the ocean's surface exists at a far greater scale than is visible on the globe. However, there is this pervasive ailment or problem that's afflicting the oceans globally, and that's what I consider to be the scourge, which is ocean deoxygenation, or what's more commonly known as a dead zone. A dead zone is an ominous term that's used to describe an area of the ocean where there's no oxygen, to put it pretty simply. And when there's no oxygen present in the ocean, the animals die off, hence the term dead zone. Most often, the effects of a dead zone manifest themselves at the bottom of the ocean on the seafloor, where in areas of a dead zone, you can see animals just basically kind of strewn about, which are highlighted in that right image that you might see on the screen. And so these animals have died from asphyxiation, so basically they suffocate to death. But how do these dead zones form? And more importantly, how did we get here? How are we at a point in our oceans where there's no oxygen and there are dead animals kind of lying about? The specifics around the formation of a dead zone can be a bit complicated, and I'll try not to bore you with the details, but the primary driver for their formation is essentially nutrient over-enrichment of the oceans, usually in the form of some sort of dissolved particles, primarily nitrogen. And then through a biological process, you have the formation of a dead zone through the extraction of oxygen. And so that might be a bit overly simplistic, but I think the best analogy that I can use to think about it is, think of a farm or garden. You add nutrients to your farm or garden with the hope of incentivizing or promoting plant growth. And the same thing happens in the oceans. If you add nutrients into the oceans, you facilitate this plant growth, and then through this biological process, you have the extraction of oxygen. And it can be a normal process at times, but when it's over-exacerbated by human influences, or humans dumping a bunch of nutrients into the ocean, that's when it kind of overloads the system and you have the reduction of oxygen and the formation of these dead zones. So the take-home message is over-enrichment of the oceans with nutrients, biological process occurs, and the end result is the development of a dead zone. Now, nutrients get into the ocean a number of different ways. There's runoff, and that's essentially is if you cover your garden or farm with fertilizer, it might rain and kind of washes the excess nutrients into some sort of stream or water body that then dumps into the oceans. And this is the primary mechanism or method for enriching the oceans along in the developed world. So areas like the US, the Western world. And it's probably one of the more primary methods for ocean enrichment in the world. Another method is sewage effluent. This is another huge culprit, and this is primarily a big issue in developing countries. So untreated sewage that is washed out into the ocean is nutrient rich and can cause dead zones. And this is primarily due to just the lack of infrastructure in place to be able to handle and treat sewage. And then honestly, another method that's often overlooked is ocean enrichment due to deposition or the raining down of nutrients from the atmosphere. Basically, you have particulate nutrients that are in the air. So, and then either through rain or just through natural settling, they deposit down to the ocean. And in some areas of the world, the enrichment of nutrients from the air accounts for almost 25% of ocean enrichment. So you can see that there's a number of different methods and sources that nutrients end up in the ocean, primarily through human activity. And that makes trying to handle and deal with this nutrient enrichment to resolve dead zones a really complicated issue. And the number one culprit for nitrogen in the air is, of course, fossil fuels, primarily in the form of car exhaust. Nitrous oxide is what is essentially emitted from the exhaust of cars, and in a lot of areas where you have a lot of human population density, lots of cars driving around, pumping out car exhaust into the air, you have huge raining down of that, those particles back into the ocean, enriching the oceans. So currently, in present day, there are more than 500, maybe more than that at this point, there are more than 500 dead zones all over the world. And when you look at where they occur and even the history of their development over time, there's this really tight spatial correlation or spatial relationship between human population density, or essentially overpopulation of humans, and the location of dead zones. So let's take a step back through time. This figure here that you're looking at is a map of the Earth, and it's showing human population density, or where on the Earth there are locations where there's high numbers of humans. And so in areas where you see the pink, the red, the orange, those are areas where there's lots of humans. And in areas where you see the colors that are green, those are areas where basically there's no human settlement. And then on the map, you'll see these different dots that appear, and those will be the locations of dead zones. And then for those of you who might like graphs, at the very bottom of this map, of this slide, it shows a graph showing the relative number of dead zones through time. So as we'll step through time, we'll see just how pervasive this problem of dead zones is for our planet, but also how relatively new this phenomenon is. So starting in the early 20th century, essentially maybe 100 years ago, you can see there are basically no dead zones that were being recorded. I think maybe one or two here or there, primarily along the northeast of the US and in a few locations in Europe. But then by the mid 20th century, the number of systems, locations that were reporting ocean deoxygenation began to increase, but were still largely contained to North America and Europe. However, just 20 years later, in the late 1900s, starting to get close to the 21st century, the number of systems and areas reporting dead zones begin to have a more global inclusion. And the picture becomes a bit more clear as the spatial relationship begins to emerge between where these dead zones are occurring and where humans are at their largest numbers. By the late 20th century, most coastal systems or most areas in the ocean that are in close vicinity or located near these large areas, large human population centers, were reporting dead zones. As you can see, the numbers are just all over the place on this map. The global breadth of ocean deoxygenation essentially just has been exacerbated, as I touched on earlier, by human nutrient enrichment of the oceans fueled by the runoff of fertilizers, sewage effluent, and the burning of fossil fuels. And the trend that we have observed basically the 20th century continues on into the 21st century. As I mentioned before, there's more than 500 documented cases of dead zones. And honestly, every single year, more and more areas and locations are being discovered. It's really kind of a mind-blowing number of locations all around the world where there's no ocean oxygenation. So why are these areas important? And why is the formation and the prevalence of these areas an issue? I think, to echo the sentiment of the American Lung Association, I think they say it best: when you can't breathe, nothing else matters. It's that serious. Oxygen is essential for all animals, even those in the ocean. And when it's reduced or when it's removed, it can have catastrophic consequences for the ocean environment and ocean productivity. Also, dead zones in the ocean tend to occur and develop in areas of our ocean that are the most productive. So these are the areas where we're getting the highest return for like fisheries landings, or has the highest numbers and diversity of like species and organisms. And this is occurring both in estuaries and on the continental shelf. We derive more than 95% of our seafood from areas of the ocean where dead zones occur. So the occurrence of these dead zones are a pretty big shock to the system and have the potential to completely have catastrophic consequences for our ocean productivity. So what does the seafloor look like during these periods where there's a dead zone? Often, I think when we think of the seafloor, we view it from this kind of top-down perspective, what we're seeing here. We're looking down at the bottom of the seafloor. But in order to really understand seafloor health, we need to look beneath the seafloor. So we kind of need to peel back the lid and peer beneath. And when we peek beneath the seafloor, it really kind of looks more like an ant farm. So you're looking right now at a profile of the seafloor. And on the left, we have a healthy seafloor, and on the right, we have an unhealthy seafloor, one that you might see during an ocean dead zone. Healthy seafloors are primarily this rust red-brown color that you see extending deep beneath the seafloor surface. So at the top of this image, we have the seafloor surface, or the sediment, the seafloor, and then the water columns here, or the ocean, and then kind of going down away from the seafloor surface this way. But yeah, this rust red-brown color is an indication that the seafloor is oxygen rich and full of large and diverse organisms. And then you could contrast that with the image on the right, which is an unhealthy seafloor. That's this dark grayish black color, indicating that there's little to no oxygen and the area is lacking large animals and diversity. So an area that you might expect to see during a dead zone. And when the seafloor is healthy, this is what it looks like. There are tons of animals burrowing through. There's animals moving across the sediment surface. We have worms that are burrowing. The seafloor is just chock full of worms, very similar to what you might find in like your garden. And it's just a very active, dynamic place. But when the seafloor is unhealthy, it looks more like this. There's very little activity that's going on from animals within the sediment. And what you're really seeing up here is just bacteria. These are like tiny little microbes that are growing, proliferating, dying, settling, and that process is kind of continually reproducing itself. It's a much more different perspective than what you see from a healthy seafloor. So most of the things we've been talking about for dead zones is just really kind of what they are, why they're bad, how they can affect us. But there is some encouraging news. The formation of a dead zone is not terminal. That's to say that whenever a dead zone occurs, its presence isn't permanent if we as humans take the appropriate measures to help relieve the system from its stress. And the primary way that we can do that is by managing the nutrients that we're pumping into the ocean. So there have been a number of locations around the globe where nutrient management techniques have actually helped alleviate or reduce and rid an area of a dead zone. And I'll highlight two specific locations. One is in the Black Sea, which is located, where's my little cursor? Oh, one is in the Black Sea, which is located just right here. Like, hopefully you can see on the cursor. And the other is from Tokyo Bay. And each one has a different instance on how nutrients ended up being remediated. But just to talk through it, for the Black Sea, during the late 1960s or the mid 20th century, nutrients were getting heavily pumped in. And this is during the period when the Soviet Union was at its height and its peak. So this particular area was essentially surrounded by Soviet states. The Soviet Union collapsed, the economies of all those countries collapsed, and as a result, the productivity and production also collapsed. And so the nutrients being pumped into the Black Sea was reduced. And the dead zone that was in the Black Sea recovered. And for quite a bit of time, 20, 30 years, there was no dead zone in the Black Sea. But more recently, as the economies of these countries has recovered, the dead zone or instances and indications of a dead zone have started to reappear again. So we can see that this was an economic collapse due to political instability that reduced nutrients and caused the dead zone to be alleviated. The other example is Tokyo Bay. Leading up into the early 1900s to the early 20th century, Japan was a rising power, imperial power, and with a lot of economic might, and as a result, pumping lots of nutrients into Tokyo Bay, and we have the development of a dead zone. Following their loss in World War II and the collapse of their economy, the amount of nutrients being pumped into Tokyo Bay substantially decreased, and the dead zone in Tokyo Bay recovered and was no longer prevalent. So those are kind of two examples of how when you reduce nutrients, both from different instances, neither was necessarily voluntary, you can actually help cure these dead zones. And finally, this is just kind of here's where we are now. There are dead zones all over the world. They are a persistent concern, and without active approaches to reducing nutrients being pumped into our oceans, this problem, the scourge of ocean deoxygenation, will continue to plague us. And with that, I will take any questions.
Great, thank you so much, Kersey. I see that we have a question coming in from YouTube, and that is, are all dead zones caused by human activity?
Ooh, that's a very good question. The short answer is no. There are naturally occurring dead zones called oxygen minimum zones, and they typically occur on the western coast of continents, and they're developed through this process of upwelling, which is essentially a natural process by which nutrients are injected into areas of the ocean. And that process mimics what you see when humans dump nutrients into the ocean. And so you get these zones where there's no oxygen and it's naturally occurring, but they're relatively limited in size and certainly in spatial scope globally. What we see from human-driven dead zones has a much broader spatial scope and a much larger size. I think the largest dead zone is off the coast of China, and it's probably 40,000 square kilometers. And the largest dead zone in the US is in the Gulf of Mexico. It's roughly 20,000 square kilometers. And so to kind of put that into context, the Gulf of Mexico dead zone is roughly the size of New Jersey. And the East China Sea dead zone is double that size.
Wow. So with the dead zones that occur naturally, do we see the same sort of impact on the marine life that would live there, or do they kind of just avoid that area?
Yeah, that's a very good question. In each instance, the animals that are able to avoid the areas of the dead zone do. And you actually see this edge effect where the animals are kind of congregated right at the edge of the dead zone as they've been kind of pushed out. The difference is that for the naturally occurring dead zones, because they've occurred over really centuries, maybe even eons, there are animals that are especially adapted to living in those particular regions and locations because they have existed there for such a predominantly long time. The human-driven dead zones are a relatively new phenomenon, and so the evolution of animals that exist in those particular areas and locations are not such that they are adapted to dealing with this lack of oxygen that is relatively new for them.
That's really interesting. So one other question we have coming in from YouTube, you touched on this a little bit, but is how can dead zones replenish? So is it always something that where humans have to intervene to replenish a dead zone, or can they kind of replenish on their own?
Yeah, it's another really good question. When it comes to the dead zones that are driven by human nutrient enrichment of the ocean, that they only occur because of human activity. So in those examples that I provided before, if the human nutrient enrichment of the ocean ceases by any means, whether it's recognition that we are causing this issue and we take nutrient management steps, or our economy collapses, or we lose a war to some effect, and that causes the nutrients that we're pumping into the ocean to be reduced, then you see time and time again that the dead zones essentially abate, or they disappear, they're cured, or they're ill. So it's a very there's a very direct correlation that exists there, and the method of achieving it is very simplistic. The complication comes from the sense and recognition that oftentimes, again, nutrients that are going into these water areas that are then forming dead zones often are coming from multiple different states. So there's kind of the socio-political aspect of it, or they're coming from the atmosphere, which, you know, again, makes it even more complicated to handle and manage the nutrients. So it's what needs to be done is clear, it's nutrient management. How you actually achieve that is a much more complicated prospect.
That sounds very complex. Two more questions coming in from YouTube, and that is, what animal is most commonly found in a dead zone, and how did we discover dead zones? How did we find them?
Oh, those are great questions. What animal is most commonly found in a dead zone? Probably, if you consider them animals, microbes. I mean, they just thrive. I don't necessarily consider microbes animals. They're not really in the animal kingdom oftentimes. That's the kind of bacteria we're talking about, but they're the organisms that are most commonly found within a dead zone. Probably worms. There are some worms that are adapted to dealing with low oxygen, and you can see them kind of burrowing around. And the image or video that I showed, where it was a picture beneath the seafloor during a dead zone experience, you still saw these tiny little like burrows being formed, and those are from tiny little worms that are specifically adapted to dealing with low oxygen conditions. But when you compare like that level of activity, the size of those worms, their productivity for the larger ocean is substantially less than what you would see in an area where there's lots of oxygen. And how was the first dead zone discovered? You know, to be honest, I don't know the answer to that.
That's okay.
But I have to go look that up now, since it's a stumped question.
Sounds good. So I know that you mentioned WormCam, and you talked about, you showed some footage of it. Can you tell us a little bit more about how did you come up with WormCam? Is it a product that was already out there that you just decided to use? Can you talk about that a little bit more?
Yeah, definitely. So I didn't get too much into the specifics of how I was able to capture some of the images of the seafloor, both above and beneath, that I presented to you all today. But those images essentially come from this specialized camera called a sediment profile camera that allows you to look beneath the seafloor surface without kind of disturbing it. And an iteration of that is what we call WormCam, which is a camera system that I developed when I was in graduate school many years ago. And the approach, again, is that recognizing that a lot of the ways that you want to be able to help understand what's going on the seafloor, you need to be able to see beneath the seafloor. You think about like the ocean bottom in areas like coral reef, or like a seagrass meadow or kelp forest. A lot of the important concepts and organisms and structures are right there at the surface. So you can just kind of scuba dive down and see them and understand like, oh yeah, this is healthy, this is not healthy. But the vast majority of the ocean, like the 99% of the ocean, is soft bottom, muddy bottoms that you saw in that photo. And a lot of the structural complexity and the important functions and animals and organisms are all beneath the surface. So you have to figure out a way to be able to observe and document those without disturbing them. And that was the impetus for the development of the camera system WormCam. I did see that we had a
So
chat question. I don't know if
yeah, yeah. Before we go to the chat question, I just have another question about WormCam and you working in undergrad. How did you discover that your passion was the seafloor? Because most of us wouldn't think, that the deep sea floor is as interesting as it is.
Yeah, it's a great question. I would say that, like many students who are transitioning from undergrad into graduate education and trying to discover what my passion was and what I wanted to focus on, I didn't really know. There were a lot of different things that I was interested in studying, and I decided that I would just choose one and follow that path and see where it took me. And it just so happened that I'm a firm believer that if you are interested, have a kind of inquisitive personality. It doesn't really matter where you apply it, as long as you're kind of being satiated with that intellectual curiosity. And so I think if I had gone down the road of any of the other things that I was thinking about studying, I would have been equally as passionate about them. It just so happened that I went down the road of studying muddy bottoms, and here I am.
I love it. I think that we need people that study muddy bottoms. So thank you. So the question that we had from our chat is, can dead zones move?
That is a good question. They don't move in the sense of thinking about movement in like a locomotive aspect, but they can shift. So in terms of like their size and their development. So for example, I think the dead zone in the Gulf of Mexico is a great example, because every year it varies in its size and specifically what area of the Gulf of Mexico that it develops in. But roughly the area that it forms and develops is within a relative region that is reoccurring. So they don't move, but there is variability in where they occur and the breadth and size of which they're occurring.
Great, that was a great question. Anybody have any other questions?
One thing that while we wait to see if there are any other questions,
Sure.
One thing to think about is what the everyday person can do to help alleviate our kind of impact on the oceans as it relates to like nutrient over enrichment. And I think the best way to think about this is thinking about the context of like, how do we get there? So we know that we get there with dead zones because of nutrients. And so what are the kind of like everyday things that we may or may not, we may do that we're not necessarily aware of that contribute to nutrient over enrichment of the ocean? One example is driving around in cars. If you have the opportunity to take public transportation or carpool, that reduces the numbers of people that are like driving individual cars and contributing to nutrients being pumped into the atmosphere that then settle down to the ocean. Another example is adding fertilizer to your lawn. If you have parents who have a beautiful, pristine lawn, that is only possible because of fertilizer. And whenever it rains, that material ends up in the ocean through any series of pathways, whether it's into the sewage drainer, which then dumps out into the ocean, or just running right into a river or stream that then pumps out into the ocean. So these kind of like little micro things that you can do that can have a huge impact, especially if it's magnified with a number of people kind of taking awareness of like their actions and how that has an impact on our wider environment.
Now, when we talk about what we can do, are things like phosphorus from, a laundry detergent, would that be something that someone could change to help lessen their impact on a dead zone?
Oh, certainly, without a doubt. It's one of those nutrients or one of those elements that contributes to nutrient over enrichment of the ocean, and certainly reducing that usage has a big impact on enrichment.
Great. Are dead zones, do they occur in freshwater, or is it just an ocean saltwater situation?
That's a great question. They do occur in freshwater. The mechanisms for them to occur are slightly different in terms of like which nutrients are driving the development, but there are some freshwater dead zones. They're not as prevalent, and that's predominantly because of freshwater systems kind of constantly turning over, whereas when you get to marine systems, there's more stratification that exists, and you're kind of getting into a bit of like ocean physics and how that occurs, trying to keep it at a more higher level. But yeah, certainly you can have locations and areas where they occur in freshwater. oftentimes the freshwater dead zones are what they call diel, which means that they occur at nighttime, but then during the day, the system becomes reoxygenated again, and that is due to a combination of biological, physical processes.
Very cool. So are dead zones dangerous for people? Could they swim in them? Do we want to avoid them?
That's a great question. I think, and from the context of like worrying about whether or not you're going to asphyxiate and die from swimming in a dead zone, that's certainly not the case. I think that for first, if you were swimming underwater in a dead zone, you'd probably have a scuba tank and a regulator, so you'd have your own self-contained oxygen, so you'd be fine there. The one concern would be that the presence of a dead zone does suggest and imply that there has been nutrient over-enrichment of this particular area of the ocean or water body. And oftentimes that has other negative effects that could pose potential risks. So for example, we know that when you over-enrich the oceans and provide a lot of nutrients, in addition to the formation of dead zones, you get harmful algal blooms that form, and they can produce toxins that are dangerous to fish, and maybe they might end up with like a rash or something to that effect. So there are like these kind of ancillary effects of nutrient over-enrichment that the formation of a dead zone implies are happening that could have potential other consequences.
Great question. Do you know if aquaculture impacts dead zones?
That's a great question. And there's a lot of speculation surrounding this. Aquaculture is something, especially open ocean aquaculture, is something that is relatively new and kind of taking off with minimal regulations. So right at the current state, and even less kind of studies that have been designed to investigate the direct effects. Some of the early studies have shown that because you're concentrating animals within a particular location and they're pooping or defecating, which you can essentially think of as like untreated sewage within a developing country, and it's all kind of settling in this localized area, you do have these localized enrichment events that occur that can cause kind of localized dead zones. But those tend to be very localized and not kind of extending into like the breadth of like ocean basin level dead zones that we see driven by human enrichment.
Very good. And can you again, just one more time, kind of go over how the size of a dead zone could vary? So, you know, what's the biggest and what's the smallest, so we can kind of picture it in our heads?
Yeah, definitely. I mean, the smallest dead zone that you could possibly experience, you could probably go out into like a creek in your backyard if you have a creek in your backyard. And at nighttime, there's probably no oxygen in that creek. It's just depending on how stagnant the water is. So you can have, you know, a dead zone that's literally like the size of this. And then you get these massive basin-wide dead zones that are driven oftentimes by nutrients that have essentially been collected throughout a country and deposited into the ocean. So for example, the East China Sea I mentioned is the largest dead zone in the world. And that comes from and occurs because there's this river, which of course I'm blanking out on the name now, that flows through China, through all these different provinces where there's agriculture occurring, and all these nutrients are getting dumped into this river, and it's just collecting essentially like all the nutrients in China, and it just dumps it all out into the East China Sea. And so as a result, within this heavy pumping of nutrients to this area, you get this massive development of this dead zone that is 40,000 square kilometers. And the same example happens in the US. The Mississippi River, which runs right through the heartland of the US, through all that farm country, gets all the fertilizers from the farms that end up landing and deposited in the Mississippi. And the Mississippi just dumps right out into the Gulf of Mexico. And then you end up with the development of this massive dead zone in the Gulf of Mexico, which is 20,000 square kilometers. And then to put that into spatial context, the size of the the size of the Gulf of Mexico dead zone is roughly the size of New Jersey. And so then the East China Sea dead zone is basically double that size.
So I know that, and I think a lot of people watching have heard about the plastic problem in our oceans. And I'm just curious, you know, we talk about the Great Pacific Garbage Patch, or these big areas of lots of, you know, tiny debris of plastics. Have you seen any correlation between plastic pollution and this over-fertilizing kind of dead zone areas?
That's a good question. There's not been any correlation or cause and effect that I've observed in the literature or firsthand. I think that The plastic problem, especially microplastics, is a really important issue, especially as it relates to those microplastics getting into the food chain at such a low level on the food chain and then kind of biomagnifying up as each smaller animal gets eaten by a larger animal before you get up to humans. And that is certainly a really important topic, concern, but there's no correlation really between how that kind of negative effect on the bottom and the issues associated with a lack of oxygen in the ocean. They're kind of being driven by, again, by humans, but from different processes of human activity.
Great, thank you so much. So I think we're gonna wrap up there, but I just wanted to thank you, Kirsty, so much for taking your time to talk to us today and teach us all about dead zones. We encourage everybody to go follow along. Did you want to talk about any of your social media again real quick?
Oh yeah, sure. If you have any other questions about dead zones or really anything about the seafloor, you're more than welcome to shoot me questions through my Twitter handle @wormcam. I'm pretty responsive to any sort of random questions that I get on there, and I check it pretty regularly, as well as that's really the only social media that I'm most active on.
Great, thank you. And again, thank you so much for taking the time to join us and share your wisdom with us today. EarthEcho International would also invite all of you watching to join us for all of our exciting programs. And you can see all of our programs here. Stay tuned to earthecho.org to find out more information about all of our exciting programs and also more virtual events just like this one. We are also excited to announce a brand new competition from EarthEcho International, which my boss, Philippe Cousteau, is going to tell you about here in a second.
I'm Philippe Cousteau, and I am so excited to announce the latest program from EarthEcho International. It's called the EarthEcho Challenge, and it's a new way for students to protect biodiversity and get the funding to do it. The EarthEcho Challenge empowers teams of middle school students to explore their community, identify threats to local species, and then submit an idea for a project that will help to restore a healthy ecosystem. 10 finalist teams will join EarthEcho International in Washington, D.C. to present their ideas, and the top 3 teams will be awarded grants to turn their project into a reality. Go to ourechochallenge.org and join our STEM competition by submitting your plan to change the world.
Great, and for all our teachers watching out there, the deadline to submit your student's plan to save the world is March 22nd. So make sure you get online and check out the EarthEcho Challenge. We also want to encourage you all to stay connected with EarthEcho on our social media channels and our website. A special thank you to the Northrop Grumman Foundation for the support of our expeditions program. I would also encourage everyone to check out our website, earthecho.org. We have a whole expedition called Into the Dead Zone and Beyond the Dead Zone, which shows engaging videos and some lesson plans all about dead zones. So on behalf of EarthEcho International and Kirsty, we thank you for joining us and keep exploring, everyone. Bye.